And today we're going to talk about the pH scale. Okay, the pH scale is used to determine how acidic something is, a solution is in water. Okay, normally the pH scale ranges from 0 to 14. However, as you'll learn with some problems in the next week or two, the pH scale can be outside of that range. Okay, the pH scale, when we talk about it, is from 0 to 14, but things based on the concentration can fall outside of that scale. pH of less than 7 indicates something that is acidic. Okay, so anything that's an acid is going to have a pH scale of below, it's going to be below 7 on a pH scale. Anything above 7 on a pH scale is basic, and 7 indicates a neutral solution. pH is defined as the negative base 10 log of the hydronium concentration ion. So pH is equal to negative log of H3O plus, or pH is equal to negative log of H plus. We talked about yesterday that H plus combines with water to make hydronium. Okay. An important note about this is that the only thing that matters, significant figure wise, are the numbers after the decimal. Okay, the numbers after the decimal. So 2.34 only has a pH of 2, something with 2.34 only has 2 significant figures. What that means, the 2 means, is that it means it's times 10 to the negative second power. Okay, so the 2 indicates it's going to be in between times 10 to the negative second power, is where it's going to be around. To find H plus, we do the opposite. We don't divide by negative log, but instead the opposite of the log is 10 to the negative. Okay, so to find the hydronium concentration, we would do 10 to the negative pH. So if I wanted to find the pH, if I want to try to find the hydronium concentration of something known as a pH of 2.34, I would do second log negative 2.34. A lot of people, a lot of times, forget to put the negative in there. The pOH scale is very similar to the pH scale. The pOH scale, and there's a mistake on this. This should say pOH, is used to determine how basic a solution is in water. Once again, it goes from 0 to 14 typically, but we can't have things outside this value. pOH of less than 7 is basic. A pOH of greater than 7 is acidic. pOH of equal to 7 is neutral. pOH is defined as the negative log of the hydroxide concentration. P of anything, all that P means in the scientific and mathematical world is to take the negative log of it. So I can take the PCA, would be the negative log of the calcium concentration. So once again, if I have a pOH of 5.0, that's telling me that it has one significant figure. The OH concentration of, if I want to find the OH concentration, I would do 10 to the negative pOH. And so to find the OH concentration, I would do 10 to the negative 5.0, and that would equal 1.0 times 10 to the negative fifth. Your exponent becomes the number in front. So this is 10.0 with this problem. 10 to the negative 5.0 would equal 1.0 times 10 to the negative fifth. The number in front of your pH, the first number before the decimal, it indicates what the power is to the negative power. Water, what we say, self-ionizes. Okay, water self-ionizes is that a portion of this breaks down into its ions. Okay, to H plus and OH minus. You could also write H plus as H3O plus. Okay, this happens in water all the time, but not to a great extent. This will become actually very important later on when we'll have some tricky pH problems next week where we'll have to think about this. Okay, but we can write, this is an equilibrium expression. Notice the double arrows. So we can write a equilibrium expression. Okay, we would not include H2O because that's a liquid. We do not include liquids in our equilibrium equation. So the Kw, the equilibrium constant of water, that's what Kw stands for, is H plus OH minus. We know that at 25 degrees Celsius, Kw of water is 1.0 times 10 to the negative 14. If we take the negative log of this, okay, at 25.0 degrees Celsius, we know that 1.0 Kw is 1.0 equals H plus times OH minus. So we simplified this down, and this is why we learned about pOH really. We know that pH plus pOH is 14. So if the pH is 7, the pOH is 7. If the pH is 4, the pOH would be 14 minus 4, which would be 10. Okay. This slide, I would say, is probably the most important slide. We'll talk about this as a summary of all the equations we'll talk about, what we've talked about so far. Okay. Um, these are the equations you'll use for your homework. So we're going to start calculating pH and pOH and H plus and OH minus of acids and bases. Okay. Uh, so we know that an acid, if something is acidic, its H plus concentration is greater than 1.0 times 10 to the negative 7. This means the exponent will be closer to 0, so 1.0 times 10 to the negative 6 would still be acidic. 2.0 times 10 to the negative 7 would still also be acidic. Okay. If it's basic, the concentration is less than that. So for a basic solution, the H plus concentration is less than the OH minus concentration. So at a basic solution, the H plus concentration would be less than that number, than 1.0 times 10 to the negative 7, because it's, once again, if I take the negative log of 1.0 times 10 to the negative 7, I would get 7. So that would be our neutral. That would be neutral. pH would be neutral. There would be 7. And we know that the pOH, it's going to be basic, has to be greater than 7. So my number would have to be closer to 0. So it could be 1.0 times the negative 4. So that would be closer to 0. So a neutral solution, H plus equals OH minus. So we know that neutral solution, they both have to be equal to 1.0 times 10 to the negative 7. So let's calculate pH, okay? Remember we talked yesterday about there are 7 strong acids and 8 strong bases. What defines something as a strong acid is that it completely ionizes in water, okay? So 100% of hydrochloric acid becomes H plus, okay? We have to follow our mole ratio with that. So to find the pH of a strong acid or base, okay, strong acid or base, well, to find the pH of a strong acid, we need to write our equation. So we know that we had 0.03 molar of this hydrochloric acid. So I would use my mole ratio, and I also have 0.03 molar of H plus. So we know that pH is negative log of H plus. That's 1-to-1 mole ratio. pH would be equal to the negative log of 0.030, which is 1.52. So at something with a strong acid with a 1-to-1 mole ratio, you just take a negative log of the concentration. Now calculate the H3O plus of a solution with a pH of 4.32. Now we know that because this is acidic, we know that the H plus concentration will be greater than 1.0 times 10 to the negative 7. So to do this problem, we do H plus equal 10 to the negative pH. So H plus would be equal 10 to the negative 4.32. Only 2 significant figures. The thing after the pH decimal is what affects it. So H plus would be equal 4.9 times 10 to the negative 5th. Okay. So a strong base, a pH with a strong base is a little bit more work. Okay. To find the pH strong base, I need to write my equation first. Okay. So we know that there's a 1-to-2 mole ratio here. So 0.010 moles of calcium hydroxide would give me 0.020 molar of hydroxide. Okay. So the easiest thing to do with this, there's a couple different ways to solve pH of a base. The easiest way I feel like to do is to take the pOH first. We know pOH is the negative log of the OH minus concentration. And because this was a group 2 strong base, it was double the concentration. So the pOH is negative log of the OH concentration. And so my pOH is 1.70, but I have not answered the question. I asked for the pH of this. So we know that pH plus pOH equals 14. So to find the pH, I would do 14 minus the pOH, which would be equal to 12.30. Second example, calculate the pH of a solution made by dissolving 2.0 grams of potassium hydroxide in distilled water and diluting it to a total volume of 250 milliliters. So I know that I need to find a concentration. When I find the concentration, I need to find my molarity. Okay, so this is where we have to be able to do molarity first. As Hannah pointed out yesterday, this is really building on a lot of stuff that we had done. So we have to be able to find the molarity first. So I need to find the molarity of the solution. I would first find the moles of the solution. So I would do 2.0 grams over 1 multiplied by 1 mole over the molar mass of KOH, and that gives me 0.0356 moles of KOH. I still haven't found the concentration, because I know the molarity is moles per liter, so I need to divide that by the liters, not milliliters, of the water. So 0.250, 0.250 gives me a concentration of 0.142. Now, this is a 1-to-1 mole ratio. We know that potassium hydroxide is a strong base. If I write the equation out, it goes to K plus OH minus, so it's a 1-to-1 mole ratio. So my concentration of hydroxide would be equal to 0.142. Now to find my pH, I find my POH, find the negative log of OH minus concentration. So I plugged in that concentration that I found, 0.142. And I find that my POH is 0.0847. Okay, still haven't found the answer yet because I asked for pH. So to find the pH, I do 14 minus the POH to give me 13.153. A base, and this makes sense, a base should have a pH of something greater than 7. Something greater than 7. So that is our lesson for the day. And if you have any questions, please email me and let me know.